Started with this. Sorry that last one got a little lengthy. Current flow through any resistor in series with the voltage source will be equal to the total current. What we're talking about here is, let me pull up some pictures. Let's go with this one. So if you look at this picture, here's the voltage source. Everything that flows out of the voltage source has to go through R1 and R4 before it returns to the voltage source. R2 and R3, there's a option. So there, R2 and R3 are parallel. But R1 and R4, everything has to go through those two. That's what series is. They are in series with each other. And the voltage source. And all the current has to go through all three of those devices. Okay, which branches have the same amount of voltage drop? So here, your two branches, let me pop open that picture. So your branches are here. So let's put a red box around them. So you have a right there and right there are connections that the current can split, and your two legs are here and here. So leg R2, and then there's leg R3 and R4. These two are in series, but they are a parallel leg. You can see that, right? All right. So R2 and 3, 4. I'm glad everybody was like, yeah, 1 and 2, that's bullshit. No. 3 and 4, resistors 3 and resistor 3 and resistor 4. Oh, I should have just done that. Resistor 3 and 4 are in series with each other, so by definition they will not have the same voltage. If you watched my previous video, I worked this circuit and showed all of everything. Now just close that paint that copy of it where I had worked it, or I'd have just shown it on the screen right now. My bad. What happens to the supply voltage in a combination series parallel circuit? So, what happens to the supply voltage? The total voltage is dropped across the components. That is what always happens to voltage. Their voltage is never stored. None of it ever remains unused at the source, and none of it returns unused to the source. So, of your 4 options, only one of them is acceptable. Okay, Ohm's law can only be applied to series and parallel circuit. Yeah, this is false. Kirchhoff's law is always relevant and it should always be used, but it's not. Ohm's law is over and above. Like, Ohm's law is what you'll actually use to find numbers and stuff. Kirchhoff's law is, it's a thing that you know. Like, you all should know Kirchhoff's law by now, but we've never really called it Kirchhoff's law. So it's one of those things that, like, you know it, you just don't know the name, and that's it. Like, that's all you get. All right. For combination circuits, trace the current paths through the circuit to determine which resistors are connected in series and which are connected in parallel. True. Yes. Good job, everybody. 3 resistors in parallel can be reduced to a single equivalent resistor. Yes. So, any number of resistors in series or parallel can be reduced to a single equivalent resistor. That's the crux of doing DC theory, is combining resistors until they're one resistor. And that's what R total is you've combined everything into a single equivalent resistance. Alright, no matter how complex, a combination circuit can be reduced to a single voltage, current, and resistance. Yes. Yeah, that's what R total, E total, and I total is. So, yeah. This is actually the beginnings of the concept for Thevenin's theorem, which we'll lightly touch next year before completely ignoring it. But yeah. In a combination circuit, the current leaving the source is blank the current returning to the source. Yes. Absolutely. Okay, and then last, the branch circuit currents are generally calculated by applying blank to the voltage across the branch. The voltage across the branch and the branch resistance. Yeah. Ohm's law. It's always Ohm's law. It's Kirchhoff's law. There's some really good videos by Khan Academy on YouTube. I'm not going to play them for you. But if you look up Khan Academy, Kirchhoff's law, there's some very good videos on that. And I would show them in class, but we aren't, like, having class. Alright.